Now, after talking about the conclusion part, okay, we will move on to talk about the weakness or the error. Okay. Now, in the new syllabus, okay, we don't have to mention about the strength anymore. Okay. Uh, I think especially it's because a lot of the students don't know how to write down the strength of the experiment. So I think the best thing is don't write down strength. Okay, just focus on the development, on evaluating what the weakness or limitations are of your experiment. Now, when we are talking about the evaluation, please make sure you have a framework of weakness, impact, improvement. Okay, uh, all these things consider the first weakness, and then you have a second weakness or limitation, and then you list it out, and then impact and then improvement. Okay, don't do a framework where you list out weakness one, weakness two, limitation three, okay, and then impact one, impact two, impact three, and then improvement one, improvement two, improvement three. This is not the framework that we want. Okay? When you talk about the weakness, then you talk about the discussion on the impact of this error, how is it affecting the accuracy or precision of the result. Then you suggest an improvement with justification immediately. Then we move on to the second one and then the third one. Uh, I think for this part, okay, it would be better if you dive deep into the major weakness or limitation, uh, rather having a lot of weakness and limitation, but you didn't dive deep for each of it. Okay, now, what does it mean by whether you have dive deep into each of the limitation or weakness is first you want to discuss whether there is a systematic error or a random error, and then second, okay, you want to discuss its impact, okay, on the accuracy or precision. Okay. If it's systematic, then it's accuracy. If it's random error, then it's precision. Okay. Don't mix these two up. All right, so why we say we should not be mixing these two up? The reason is because systematic error, it has a direction. Okay, it's usually either they are consistently overestimated or consistently underestimated. Okay, and remember it should align with your data. Okay, let's say for example, okay, your uh, result has shown that your result is higher than expected. Right? That means it's overestimated. Then in this case, in your systematic error, you should not mention something like gas leakage, for example, because gas leakage it should always lead up to uh, something that is lower than expected because something has leaked out, right? So in this case, it's inconsistency with your data analysis. So bear in mind, it should align with the data analysis as well. Okay. Another example would be, let's say, uh, the magnitude of the enthalpy change is higher than expected. Now, in this case, then you cannot mention heat loss to surrounding. The reason is because heat loss means that it should be lower than expected, right? It should be underestimated. Right? And so this is what we call inconsistency with your data analysis right here. Right? Now, so bear in mind, systematic error it should have a direction, while for random error it doesn't have a direction. Okay, is related to the plus or minus there. Okay. Now, usually when we're talking about random error, how it affects the precision, it would be best if you do point out the one that contributes to the greatest percentage uncertainty. Okay. We move on. Okay. There are some things that we should not, okay, add into the evaluation part. Okay. Those are what we call human error. Right? For example, you mentioned that it's overestimated. The reason is because for every titration trials, I did not wash the conical flask clean enough. Now, in this case, it's your mistake. Okay, it's not a methodological mistake, and so in this case, you should not write it down. Okay, if I'm the marker, then I would ask you, why are you not washing them properly then? Right? Or you cannot mention that, oh, because I did not read the meniscus on eye level. And that is your mistake. Don't let the marker know that you're actually stupid, right? Or you're trying to intentionally make up some error simply because you need to write down something in the evaluation part. Right? When you're writing down systematic or random error, it should be something that's methodological. Right? The second common mistake is don't blame or don't always blame the apparatus. Usually, it's not like that you cannot point out something bad about the apparatus, but usually we only point out the one that contributes to the largest percentage uncertainty. Okay? Now, why do we say that we should not always blame the apparatus? The reason is because it's actually unavoidable that every instrument has absolute uncertainty. But the thing that we want to think about is that, yes, absolute uncertainty is unavoidable, okay? But right, you can actually minimize the percentage uncertainty. Now, let me give you an example, is that, let's say in your data processing, okay, the final and initial burette reading, the change is too small. Okay? That means you didn't add enough titration. The indicator already changed color. Okay? Now, how do we improve this? Okay? Now, one way is to, for example, like, you can't change the absolute uncertainty of the burette, right? So you don't say something like, oh, I use a better instrument than burette. Right? This is unrealistic. Okay? Maybe you say, maybe you make the concentration of the titration a little bit more dilute so that the final and initial burette, that change is larger so that the percentage uncertainty is lower. Okay? In this case, then it would be a better way of evaluating it. Okay? Now, don't mention any apparatus that is not in the school lab. Otherwise, the marker would say, oh, why don't you use that apparatus in the first place, right? Make your improvement realistic, or rather mention it as a limitation if you really can't think of anything better. Okay? But usually when you say that, it should be a last resort. Okay? Yeah, so it would be best that you're actually pointing out an error that has a methodological improvement as well. Okay? But again, let's say if it's a really huge error, but still at the moment, you really can't think of it, at least, okay, you show your marker a thought process on why this limitation is still something that is unavoidable. Now, moving on is when the error is foreseeable, make sure your design do address that. Okay? One of the major thing is heat loss to surrounding. Okay? A lot of students, you actually evaluate about heat loss to surrounding. Okay? But the thing is, heat loss to surrounding is something that is foreseeable, right? As a marker, if I see heat loss to surrounding in the evaluation part, but I cannot see that in the design part, then what I, as a marker, would say, okay, is that, okay, it's good that you do evaluate in your evaluation part, okay, but that's low tier because of your methodological design problem. Okay? You want to let the marker know, okay, that you have actually considered, okay, how to minimize the heat loss to surrounding. Okay? Maybe you've done everything you could, but still in your data analysis, the result is still underestimated. Then in this case, you talk about heat loss to surrounding again, then it's a higher level of evaluation. Okay? Another example could be gas leakage as well. Okay, these are some of the foreseeable error. Make sure when you're really trying to address that, okay, make sure that you do consider that in the design part. Okay? And so I think that's it, okay, for the evaluation part. Okay? All the best for your chemistry lab report. Okay? Looking forward to see your good work. Bye bye.